Hello students, let us try to understand the cyclic structure of glucose. Okay, the structure first of glucose explain most of its properties, but the following reasons and fact could not be explained by the structure. So structure first of glucose is what, student? CHO is there, and CH, no, here is better to write this form, student. uh, this is a CHO. So here is C O H, and here is H, then here is again H, and here is OH, and finally whatever the carbon they are having, it is OH is there, and COH is there, student, and CH2OH. Okay, and here is H, and this is H. So these many are there. This is the first structure, student, that you can understand. Here is there in this page, like here, this is the first structure. Okay, so from the first structure they are saying most of the chemical properties, this first structure is explained what we learned in the previous structure lecture. Despite having the aldehyde group, glucose does not give the Schiff test and does not form the hydrogen sulfide addition product with the NaHCO3. Up like that, aldehydes are there, student. Okay, aldehydes are there. They react with the NaHSO3. Okay, and then they give the addition product. Okay, but what they are saying is, student. But what they are saying, glucose. If you talk about glucose, it does not react. It does not react with the NaHCO3. NaHSO3, it does not react. And Schiff base also, student. If you are talking about glucose and Schiff base, if you talk about the glucose plus if you talk about Schiff base, Schiff base, it is also not giving, reacting. It means what they are saying is, student, it means glucose does not have what, student, does not have free CHO group is not present. That is why it is not giving this many tests. Now let us read the second point. The pentaacetate of glucose does not react with hydroxylamine. Hydroxylamine means NH2OH. It is not reacting, indicating the absence of CHO group. Means if the pentamine whatever is formed, student, it is the CHO group, and CHO COOCH3. This group they are saying, that is, it is not reacting, student. Okay, it is not reacting with what, hydroxylamine NH2OH. So mean that is what, no reaction, that is no CHO group. That is no CHO group. This reaction saying that is no CHO group. Next point what they are saying, glucose is found to exist in two different crystalline form named as alpha beta. The alpha form of glucose, melting point 419, obtained by the crystallization of the concentrated solution of glucose at 303 Kelvin, while the beta form, melting point 423, okay, more, is obtained by crystallization from hot and saturated aqueous solution at 371 Kelvin. This behavior could not be explained by the open chain structure of the glucose. It was proposed that one of the OH group may add to the CHO group and form the cyclic hemiacetal structure. It found that the glucose forms six-membered ring with OH and CO is involving in the ring formation. This explains the absence of CHO group and also existence of glucose in the form of shown below. These two cyclic form exist in equilibrium with open chain structure. So see, student. Here if you talk about this one, CHO group, student, I am explaining, trying to explain. Okay, so how I am explaining, student, this is the structure, student, CHO. So CHO is there, and that is COH, and here is H is there. Remaining carbon I am not explaining here, that is it CH2OH, and this is there. So what they are saying is, student, this is also OH, and here is also OH. Here is, if you talk about, here is HOH, and here is, these are the H. So they are saying that is this carbon can be write, here is C double bond O, and here is H, right? And remaining is like that, remaining we can write CH2OH. So this is this, if you talk about this student, so they are saying this carbon student, this the first one. Okay, first one is what doing student, this is, suppose this is 1, and here is the 2, and this is 3, this is 4, this is 5, and this is 6. So 1 and 6 carbon, 1 and 6 carbon, what they are making student, they are making the single bond. So this is forming bond with the this is forming bond with this. So see what is happening student, 1 and 5th carbon is forming bond, remaining will be, that is like OH. Here is what is there student, this first group is there, but this joining is not like that student. If you talk about the joining portion is like that. This is like that, this carbon is combining like this. So here will be the OH. Okay, then it will be again, what they are saying student, again this is OH group, this is H group. Okay, and here is H, this is OH, this is H, and this is H. Okay, this is the groups are there. Okay, these are the groups are there. So in these groups, what you will be able to understand student, what you will be able to understand, that is how many groups are there, 1 2 3 4 5 6 carbons are there, and that is first and fifth carbon are getting joined with the oxygen of this. Okay, and that is what the structure of the, this is the cyclic structure of glucose, this is what cyclic structure of glucose. Okay, cyclic structure of glucose. But in this structure to differentiate there, alpha structure, if you talk about alpha, so in the first carbon, that is OH group, is right side, and while in the beta and the first, this is left side. So these two changes are known as what student, this is known as anomers. This is known as anomers, right? Now you see student, up now there is one more structure is there, the two cyclic hemistructural form of glucose differ only in the configuration of the hydroxyl group C1 called the anomeric carbon, the aldehyde carbon before cyclization. Such isomer, that is alpha and beta form, are called anomers. The six-membered cyclic structure of glucose is called pyranose structure, that is alpha and beta. In the analogy with the pyran is cyclic organic compound with one oxygen atom and five carbon atom in the ring. The cyclic structure of glucose is more correctly prepared by Howard structure as given below. So this is pyran is there student, and similarly there is glucose is having the pyranic structure like this. Okay, so that is what is there, OH groups are coming down. Okay, and here we have to memorize these two structure student. Now the next we will study the structure of the fructose. Thank you so much for watching friends.